Use symmetry to evaluate the integral from negative pi fourths to pi fourths of x squared sine x over 1 plus x to the sixth dx. Now, this integrand is pretty gnarly, so we're hoping that there's some sort of a neat trick. And I think we're hoping that this is an odd function, because if this is an odd function, that would mean that this integral is equal to 0, because we would have the positive side and the negative side canceling each other out. So what we need to do to determine if this is an odd function, well, there's a couple of things we could do. One thing is that an odd function satisfies the following property: f of the opposite of x equals the opposite of f of x. So this is the main way that we can figure out if this is in fact an odd function. So let's plug in negative x here and see what we end up with. So if we evaluate this function at negative x, that's going to be negative x squared times sine of negative x all over 1 plus negative x to the sixth. Now, when we've got negative x times negative x, that's just x squared. The negatives cancel. Now, sine of negative x, sine is an odd function, and so that means that sine of negative x is equal to negative sine of x. That's also a trigonometric identity. In the denominator, this is going to become 1 plus x to the sixth, because that negative to a sixth power becomes positive. And then we can pull this negative out front in the sine of x and write this as the opposite of x squared sine of x over 1 plus x to the sixth. And you'll note that this fraction is our original function. And so this becomes the opposite of f of x. And so that means this is an odd function. And because it's an odd function that is integrated from negative b to b, that means that that integral is equal to 0. Another way that we can look at whether a function is even or odd is we can look at the factors. If we have x squared sine of x over 1 plus x to the sixth, x squared is an even function. So we've got even times sine of x is an odd function, and 1 plus x to the sixth is an even function. Anytime we've got a polynomial and all of the degrees are even, 1 is the same as 1x to the 0. So these are all even powers of x. That is an even function. And when you have an even function times an odd function, that makes it odd. And dividing that by even still ends up making it odd. So in the end, this becomes an odd function. This is just some hand-wavy stuff. When you play around with functions enough, you get to see. And so you might get to a point where you are comfortable enough looking at even and odd factors and working with all of them. But if you are confused by that, because I didn't really go through everything in detail, the real answer for checking if a function is even or odd is if it's odd, f of the opposite of x is the opposite of f of x. And if it's even, f of the opposite of x is just equal to f of x.